Do I go 1 or 2? No, yeah. Cool. So here's the thing. So I'm going to define something I'm going to call Mn. You'll see it. I mean, we'll quit in a minute. You'll see why this is important. So Mn is my Lyapunov function at time xn. And the v could be something that grows really fast, you know, like xn to the 5th power, I don't know. So this is big. But then I'm summing a bunch of big things. So f might be polynomial. So I'm summing just massive things. So you expect this to grow like crazy. Now I'm subtracting something, but that something, you know, g is just going to be like, you know, 0 everywhere except on a finite set. So it sure doesn't seem like it's going to compensate much. But this says it does. And why is that? If I look at the conditional expectation of Mn given Fn minus 1, and now I regret my letters. You know, here I use t and here I'm using n, you know, but it's still true, right? You know, if I take t plus 1 equals n, then I can go through and take the conditional expectation of that, given the past. This is already in the past. So when I condition, I can ignore all that, and I just have that. Yeah. And what I'm going to do, stare at this, again, pattern recognition, and I forgot minus signs, everybody, right? How come you don't yell at me more? Look at this. First I forgot the v, and nobody said a word. And then what, I mean, unless I forgot it here. No, there's a minus sign there, and there's a minus sign there. Minus signs, yeah. Yeah, I know 2 hours is too long for me and you. So there's a minus sign, there's a plus sign there, but there's a plus sign there, but this is less than or equal to that with, again, t is n minus 1. All right. That is less than or equal to v of x n minus 1 minus f of x n minus 1 plus g of x minus 1, blah, blah, blah. And what's that equal to? What's that? Is it you?
Mn minus 1.
Everybody hear that? All right, so what is this sum? Does it look familiar? All right, I defined Mn. It's v of xn plus a sum. And what I ended up when I took this conditional expectation is I got, instead of a v of xn, I got a v of xn minus 1 and a sum. And there's, you can see that this knocks off one term. So it's exactly Mn minus 1. Okay, so now that's called a super martingale. So basically it says that this thing that looks like it should be growing is actually decreasing on average. And then you could pick up massive books, volume 1, volume 2, volume 3. Anything you want to know about martingales is there. And so you just crank the martingale machine and you then get this result. You know, and that's going to take a little bit of explanation. So we will crank that martingale machine on Tuesday, and from this, we will get this like in no time at all. And once we get this, a little more thought gives us this, but we need a different representation for H, because our old representation does not work. You know, so this, put a star here. This will give a star. Once I tell you a few of those tricks, you get it like that. But for H, we need a new representation for H. The previous one I've showed you doesn't work. It just doesn't. It doesn't make sense. Okay. All right. Cool. So any questions before we adjourn?
When you say new representation for H, you mean other than the inverse?
Yeah, that doesn't work. It turns out that, yeah, it's just I can't. The only representation you've seen so far is this infinite sum that I used today. And I don't know how to get bounds on that. But I can get bounds. There's a representation that looks just like this, you know, and then I can get bounds like that. And once we get it in. So yeah.
So you have to create like a new Poisson equation?
No, it's the same Poisson. There are many representations. So like with pi, there are all sorts of representations. There's an inverse formula. There's this regeneration formula. There's all sorts of formulas. And the same is true for the solution of Poisson's equation. There's many ways to express it. Yeah. And some ways are useful for bounds and some are not. Yeah, that's all. Yeah. So there's this stability theory. You know, there's a bit on coupling I think we should talk about, and then we're going to go to control. So I think again, I think that not next week, but the following, we'll start having a U in here as well, you know, and start doing some dynamic programming. Okay, are we done? Or no questions? It's all trivial. Okay. All right.